Good evening, everybody. Myself, Acharya Vishvendra, and today I'll discuss the solution of the quiz of the day with the video that I posted on 16th. So, this is the video solution with elaboration. So, here the concerned point is class 11th physics, and the topic here is potential energy. So, the first question is we have to express force as a function of potential energy and the radius or the distance. So, the expression here is if two particle system we have, and there is a distance of r between them, then the force of interaction between them is minus of del u by del r, which is also equal to negative of the slope of ur graph, which is minus of tan theta, which is further equal to tan alpha. So as you can see from over here, if we have a ur graph as shown in the figure, so corresponding to a particular point A, you just make a tangent at this point, and suppose angle from the r axis is theta in anti-clockwise sense and alpha in clockwise sense. So by definition of slope of tangent and calculus, we know the basic concept that the slope is either tan of theta or either minus of tan alpha. So here minus is common, so that will make it minus tan theta or the tan alpha. Then another question we have on UR graph, certain points are shown over here. So there is a question about point A. So we can see that point A has got a local maxima for potential energy. That means it corresponds to the position of unstable equilibrium. And since slope of tangent is 0, so certainly force is 0 at A. So it corresponds to the position of the unstable equilibrium. While for C, we can see that there is a local minima at C. So it corresponds to stable equilibrium position. So these are the things. B corresponds to a point of zero potential energy. So force is not 0 at point B. As you can see, the slope is not 0. So it's not equilibrium at all. Then we have another quiz session for class 12 physics. Topic is EMI. So here the first question is induced EMF is given by, so as per Faraday's law, the induced EMF is minus of d phi by dt, where phi is the magnetic flux passing through a closed loop. Then we have dimensional formula of induced EMF. So it is equal to potential energy per unit charge. So if you simplify this, it reduces to m1 L2 T minus 3 I minus 1. Then third question is SI unit of E. So it is volt or joule per coulomb, or from using this expression it can also be written like kg meter square second minus 3 ampere minus 1. So these are the possible answers to this question. Then we have another question like relation between volt and Henry. So it's like E is equals to minus of L di by dt. So if we compare units on both sides, we have volt is equals to Henry ampere per second. So that will be the relation. Then we have the dimensional formula for Henry. So Henry is basically inductance, and we have energy as half Li square. So using that, we have the dimension as m1 L2 T minus 2 A minus 2. Then we have next the dimensional formula for watt. So watt stands for power, and we know that dimensional formula is m1 L2 T minus 3. Then we have another quiz of the day. It is for class 10th ICSE board physics. The topic is vibrations. So the first question is how many types of vibrations we have. So we have basically three types of vibrations: the natural, the damped, and the forced vibrations. Then here is another question, examples of natural vibrations. So it's simple pendulum in vacuum or spring mass system in vacuum. Then we have example of damped vibration. It's simple pendulum in air or simple pendulum in some glycerine or some viscous substance, and spring mass system in glycerine also. This is also an example of damped vibration. Then we have examples of forced vibrations. So we have the vibrations of air columns or the concept of resonance. There are many examples of resonance which all are examples of the forced vibrations. Then next question is at resonance, amplitude of oscillation becomes maximum, and the condition of resonance is that frequency of external force is equal to the natural frequency of vibration of the system. So you have seen that we have discussed a number of questions across different segments in a very small video of, let's say, 5 minutes. So if you have any doubts, you can ask in the comment section. Thank you and have a nice day.